Let me explain you this displacement time graph. Here displacement is plotted on y-axis while time is plotted on x-axis. And this is your graph. So initially, that means at t is equal to 0, displacement was 0. Okay. And you should know that slope of displacement time graph represent velocity, right? So at t is equal to 0, we do have slope. If I have to get slope at this point, then I have to draw tangent here and angle with horizontal, let it be equal to theta. Then tan theta will be slope at this point. Suppose I have to find slope here. I will draw tangent here. Angle with horizontal, let it be equal to theta. So tan theta will be slope at this point. So you should know that in displacement time graph, slope represent velocity. So initially, that means at t is equal to 0, can I say that slope is 0? No, we do have some slope here. If you draw tangent at this point, let this angle be equal to theta, then we have slope here. So I can say displacement is 0, but at the same time, I can say slope is not 0. It has some value. And what is slope? Slope is nothing but velocity. So our particle was moving initially with some velocity. Let this be our particle. Initially means at t is equal to 0. That particle was moving with certain velocity. If you would have given me this angle theta, then we could have calculated its velocity also. But here I am assuming it just for the sake of explaining this question. I am assuming let velocity be equal to 4 meter per second. So that particle initially is moving with 4 meter per second, and I am taking this point to be origin. That means x is equal to 0. Now let's see here. Let's see this point. And I am saying let this time be equal to 2 seconds, right? So if I have to find velocity at this point, I will draw tangent here and this angle with horizontal, let it be equal to theta 1. Can I say slope is positive here? Of course, slope is positive. And if slope is positive, I can say velocity of that particle is positive. And if velocity is positive, it implies particle is moving towards plus x direction. So at t is equal to 2 seconds, our particle is moving towards right. Okay, then what else I can say or comment on this slope? As time increases, you see here, let this time be equal to t is equal to 4 seconds. So if I draw tangent here, let this be tangent, then angle with horizontal is very less here, right? So this angle is very less. So what I can say? I can say slope is decreasing. So from here, I can say slope is decreasing. And what is slope? Slope is velocity. So velocity of particle is decreasing. So initially, I have assumed that particle is moving with a speed 4 meter per second. So at t is equal to 2 seconds, its velocity should be less than 4 meter per second. I am assuming let it be equal to 3 meter per second. In future videos, I will give value of this angle as well. So we will exactly find out what is velocity with which that particle is moving. So at t is equal to 2 seconds, its speed is 3 meter per second. Now, let me ask you one question. Initially, particle was moving with speed 4 meter per second. and then its speed or velocity reduces to 3 meter per second. So, in which direction force should be acting on this particle? I'm talking about net force. Just give it a try. Okay. So, according to me, force should be acting on this particle towards left. Then this force will decrease velocity of this particle or speed of this particle. Right? When I'm saying velocity, I am talking about magnitude of velocity. So in the direction of net force, we have acceleration of particle. So force is acting towards left. So acceleration is also towards left. So I can say here that particle acceleration is towards left. That is acceleration is negative. For this complete motion, for this complete motion, acceleration is negative. This is what we have concluded. And let us check this point, that is at t is equal to 6 seconds. I'm assuming this to be 6 seconds. I know here slope is 0. And if slope is 0, it implies velocity is 0. That means at t is equal to 6 seconds, particle velocity becomes 0. Okay. So at t is equal to 6 seconds, particle velocity is 0. So it comes to rest. So initially our particle was moving with certain velocity. Acceleration was opposite to direction of velocity. So this is example of retardation. And finally, at t is equal to 6 seconds, our particle comes to rest. Now, can you analyze which physical situation is represented by this graph? Yes, you are right. It represents braking of a car. Your car was moving with certain velocity. Then you apply brake, and slowly, your car comes to rest. In next video, we will also analyze more such displacement time graph.